All right, today we are looking at a few parts of chapter 15, and we're going to focus on acids and bases in this chapter. So we first want to understand what an acid is and what a base is. An acid typically has a pH that is lower than 7, so you do have to know that, lower than 7. And we want to understand that they have more H plus ions, which is just hydrogen ions, and typically they have a sour taste. You can associate lemons with an acid, so of course any citrus has a sour taste. Now, they will react with bases to produce salts and water. Salts is just a fancy word for saying an ionic compound, and we know an ionic compound is a metal and a nonmetal transferring electrons. And they can also, so it's basically double displacement and single replacement reactions. So what type of reactions we call these? Double and single. Now bases have a bitter taste. They kind of have a slippery or soapy feeling. For example, bleach is a very strong base, and you know that if you get a little bit on your hands, it kind of feels slippery after you wipe it. That's an example of what that means. It is very caustic, meaning it is dangerous. And just like acids had H+, bases have OH- ions. We call these hydroxide ions. That's another word for them. And they have pH that is above 7. And again, they can go through a double displacement reaction as shown here. So a couple little things I want to review with you because these are such important concepts. pHs are less than 7 if it's an acid. pHs are neutral if they are at 7. And then if it is above 7, we consider that basic. And some examples you can see here. We like to say water is kind of our center, being such as a neutral or 7 pH. Anything above 7, about 7 to 14 is a base, and below 7 to almost down to 0 is an acid. All right, so we're going to go ahead and calculate these. We are going to really focus on this equation shown here. I will demonstrate how that is used. So I'm going to write that down. You will be given this equation. So this is a new kind of equation we're going to utilize. This negative log is in your calculator, so you're going to have to type the negative sign, hit the log button, and then type in the H+ concentration. These brackets just mean molarity, so you don't have to worry about those. It's just the H+ concentration. So in this example, we're going to calculate the pH. So I'm going to go ahead and rewrite that equation. And I'm going to go ahead and put that 6.0 times 10 to the -4th in there. And putting brackets actually means molarity, so I don't even need to put a unit. And in my calculator, I'm going to take negative log of 6.0 times 10 to the -4th. And my pH ends up being here 3.2. Okay, so that is an example of an acid. Let's do another one. Calculate the pH of HCl. So anything with an H in front is a quick indicator that it's an acid. We call this a strong acid, actually. So let's go ahead and calculate this again. Please try this on your own and make sure you're getting the right answer. The negative sign is essential to getting the right answer. So I hit negative, then log, and then I type my 1.10 times 10 to the -3rd in there. If you're having any trouble doing this, please ask me. So this I get 2.96, which I'm going to round to 2 sig figs to be 3.0. Okay, so another acid. Now, an electrolyte, you may have heard of electrolytes when you talk about or have drank Gatorade. Gatorade is a term of an electrolyte. Basically, an electrolyte is really just something that conducts electricity. We have 3 types of electrolytes. We have strong, we have weak, and we have non. So a strong electrolyte, what you need to know is that it dissociates 100%, okay, into ions. Now, what the heck does even dissociate mean? Dissociate is a fancy way of saying breaks apart, okay? So let me go ahead and show you. If we had a solution here, let me go ahead and grab a black. If I had a solution and it had liquid in it, like water, and I put a salt, for example, is NaCl or table salt. If I put it in here into the solution of water, it would break apart into Na plus and Cl minus. Okay, so that means it is dissociating 100%. So in this beaker, 100% of the NaCl molecules would break apart into what we call their ions. It has to have a charge. Now, a weak electrolyte means very few of them dissociate. The true number is about 1% to about 4% dissociate. So in a beaker, let's make my beaker a little bigger this time. An example would be sugar. So if I had sugar here, it'd be we'll just do glucose. C6H12O6, about only 1% of them or 2% of them would break apart. The rest of them would stay C6H12O6. Okay? So if any are broken apart, but not all of them, we call that a weak electrolyte. And then a non-electrolyte would be other types of sugars, and these are always non-ionic. Another word we call that is molecular. And they don't break apart at all. So they're going to sit in a solution and be completely together. None of them are going to dissociate. Now, you do have to know that electrolytes will conduct electricity and non-electrolytes do not conduct electricity. Okay, and you have to know strong breaks apart 100%, weak breaks apart very little, and non breaks apart not at all. So I'm not going to have you classify them. I'm just going to have you understand those terms and what they mean. So again, here is a really comprehensive list. Strong electrolytes, we said, are ionic. And what I'm going to write is SA and SB, which means strong acids and strong bases. You do not have to memorize those in this course, but if you go to Chem 1, you will. We just need to understand that these conduct electricity or heat, of course, and they dissociate 100%. Okay, so that's what you need to know about strong. Weak, we have to understand that they are usually organic, which just means H, C's and O's, and some weak bases, which you're not going to have to memorize. We know that these dissociate about we're going to say 1 to 5% or so, which is very few is really all you need to understand. And they are very weak conductors of electricity, so barely at all. And non-electrolytes, you have to know they don't dissociate and they don't conduct heat or electricity. Okay? Just a quick little review. You're not going to have to classify these. I'm not going to give you one and you have to classify strong, weak, or non. I may give you a quality and you're going to have to say, is it a strong quality, a weak, or a non? But other than that, you're not going to have to classify them for me. All right, now, remember we said when an acid, which usually has an H plus in front, base, which typically has an OH minus, it will in this class. It creates a salt, which we know to really just be an ionic compound, and water, which a lot of times will be written as HOH or H2O. Either one is fine. This is really just a fancy way of doing a double displacement reaction. So if you understand double displacement, you really don't need to do anything extra. Remember, with double displacement, the outsides pull together and the insides come together. So we have KBr, plus 1, -1 charge, and then H2O. I prefer to write this as HOH to see the H plus and the OH minus coming together, but you can do either one. So I'm going to go ahead and do this one. So HOH plus CaOH2, and then we can quickly balance that. Oh, excuse me. Losing my mind here. The Ca joins with the NO3, excuse me. And that has a +2 charge, okay? To balance that, we can go ahead and put a 2 here and a 2 in front of there. I should have saved some room. All right, so the H's are joining with the OH and the Ba is joining with the PO4. HOH, it doesn't matter what order you write these in, and the Ba with a 3 from the PO4 and a 2. Okay, so let's quickly balance that. I see a 2. I'm going to put a 2 here. It's going to be 6 H's, and I'm going to go ahead and put a 3 in front of this. Okay? All right, now, neutralization reaction or titration. You will do this, or you have done this in lab. It is the burette, the big long tube, and we go ahead and put the base into the acid and wait for that color change. That color change is going to indicate the equivalence point, which means, and you have to understand this, the amount of acid is equal to the amount of base. So that means the moles of the acid is equal to the moles of the base, okay, which is the whole concept of acid-base titration. And we're going to see some examples of which you solve for these. Now, if you want a really good video explaining this, you can Google this, neutralization, acids, bases, and salts, and the video is by Infinity Learn Neat, and you can check that video out. If you want to see, I will also link that in our files. Now, a quick review of how you did this. You usually have, or what we did was you had your acid in here with some water, just to give it more solution. You put indicator inside a couple drops. In our lab, we've had bases in here, and then we are dripping it into the acid. And you're going to continue doing that, making sure you read your level of your meniscus. When you see that we want a faint pink for these sort of reactions we've done, although there are other colors, you go ahead and read your final reading, and then you subtract the final minus the initial, and you see how much of this solution or the base solution you've used. I want to remind you that this tube is called a burette. Okay, it is a very handy titration tool. Now, these calculations were a little bit tedious, so I went ahead and did them just so that we could kind of review them together. So, first thing we do when I read a problem is I circle what I'm trying to find. And I also write down the information that I see. So this tells me 0.525 of HClO4, so I went ahead and wrote that here. And then I'm trying to find my volume. And then I see it is giving me 11.5 mils of this 0.3 CaOH2. So again, I wrote that information out. And now some important things you need to know is the molarity equation, which will be given to you on any exam, and then 1 liter is equal to 1,000 milliliters. You will not be given that on any exam, so make sure you know that. So I actually numbered these steps out for us to make it a little bit easier. Step 1 was I used the piece of information that gave me both parts. Since I had 2 pieces of information here, I could go ahead and do my step 1 right here. What I did was I used my molarity equation, and I knew I just quickly converted my milliliters into liters because you have to have it in liters for that equation. And I multiplied both sides to solve for moles. If you move down to step 2, I went ahead and used my moles and did stoichiometry. Since this is a balanced equation, I used the 2, which I found in the balanced equation, and the 1, which was in front of the CaOH2. And this switched me over to my moles of my HClO4. We call that perchloric acid. And then step 3, I just redid the molarity equation because remember, this step is able to be done because it's a balanced equation and because this is titration, meaning the moles are equal to each other in a balanced equation. Okay, you just have to use the coefficients to counteract them. So now I used my molarity given in the initial problem. And I was solving for liters here, and I used the moles I just solved for and solved for my liters. Now that one last final step is asking for this in milliliters, so I went ahead and converted from liters and used the milliliter to liter conversion and ended up with 131 milliliters of HClO4. Okay? There's a second example down below if you'd like to pause and go ahead and try that on your own utilizing the problem shown here, but I do have it again here. So again, I like to see which one gives me 2 pieces of information. It's the NaOH in this circumstance, so I'm going to go ahead and start with that, and I can solve for my moles. I use my moles to then go to what I'm trying to find using a mole ratio. I ended up with moles and went ahead and this problem asked me to solve for molarity, so I had moles over liters, and I ended up with a very small molarity of sulfuric acid. So that is really all we're focusing on in this chapter. So understanding acids and bases, the big thing here being the H plus and the OH minus, and also the pHs being above and below 7. How to calculate pH, you will be given this negative log equation. You just have to know to put the H plus in there. Then how to use the negative log button. You're going to just have to I'm not going to really have you categorize them as strong, weak, or non. I just want to categorize the qualities. I told you dissociation and conductivity, okay? So we are going to have to work on predicting products, of double displacement reactions. So you're going to want to go ahead and look at that. I know we call them acids and bases, but I just like to think of them as double displacement. And last, titration calculations, solving for volume and molarity. Okay? Thanks for listening.